negative, but it is constant. Once again, area under the curve and above the x-axis, you will get the displacement. Now talk about the displacement time graph. If this is the displacement time, there are two types of parabolas. All these are parabolas only. In the previous case, the parabola was like this. Why was the parabola like this? Because the slope should be increasing. Now in this case, the parabola will be like this because the slope should be decreasing. Here, slope implies velocity should be decreasing. If you observe carefully, if this becomes flat, slope at the highest point will become 0. Why should the slope at the highest point become 0? Because the body is decelerating. So there are two types of parabolas that will come across for you as far as displacement time graph is concerned. If the body is subjected to uniform acceleration, one will be this, the other will be this. One will be this, the other will be this. Are you able to see that? In the sense I am speaking about these two types of parabolas. This is the curve for which the slope is increasing. This is the curve for which the slope is decreasing. Is that clear?
Yes, sir.
Unless and until specified, we will consider every parameter in the upward direction as positive, every parameter in the downward direction as negative. For a body which is thrown vertically upwards, motion in a vertical direction, everything in the upward direction is considered to be positive, everything in the downward direction is considered to be negative. Look at the first thing here. Write down this problem. A body is thrown vertically upwards with a velocity of 9.8 meters per second. Draw the ST, VT, AT graphs for whole of the journey. What do you mean by whole of the journey here? Try to understand one point. What do you mean by whole of the journey? Whole of the journey means you have projected it, it goes up and comes down. I'll do the job. 1 second, listen to me. 1 second, your attention. When you throw the body, it goes up and it comes down. So you are starting from u equal to 9.8 meters per second. When it comes back, it will come back with 9.8 meters per second. When you throw a body in the vertically upward direction, when it comes back to the point of projection for you, the velocity will be the same but in the opposite direction. The velocity will be the same but in the opposite direction. So when you projected it, it comes back. How much time does it take to come till here? V equal to u minus gt. 0 is equal to u minus gt. The time will be u by g. This is 1 second. It takes 1 second to go up and 1 second to come down. So now when I draw the everything in the upward direction is positive, everything in the downward direction is negative for me. That's the reason why u I have taken as positive, g I have taken as negative. Everything in the upward, is it a must that I take the same sign convention always? No. Depending on the problem setter, he can change the sign convention. He can tell you everything in the downward direction is positive. All that you will be doing is multiplying whole of the equation with a negative sign. Now, V equal to U plus AT you have used here. It goes up and comes down. How do you draw the AT graph? Total time of journey is 2 seconds. Do you all agree with that? Now for the first 1 second and 2 seconds, the acceleration was 9.8 meters per second square. Either when the body is going up or when the body is going down, acceleration due to gravity is only in the downward direction. Either when the body is going up or when the body is going down, acceleration due to gravity is only in the downward direction. Is that making sense? Hence, for both the times, time of ascent and time of descent, I have drawn A as minus 9.8 meter per second square. Now come to VT graph. This is VT graph. This is 1 second. This is 2 seconds. Now initially the velocity was 9.8 meters per second. Initial velocity, what makes you think is positive? I threw the body in the upward direction. Everything in the upward direction is positive. So initial velocity, you consider that to be plus 9.8 meters per second. But after 1 second when the body reaches the highest point, after 1 second when the body reaches the highest point, the velocity there becomes 0. So from 9.8, I should reach the x-axis in 1 second. And the acceleration is uniform. So it should be a straight line. And that straight line should be giving me negative slope. Why should it be giving me negative slope? Because the slope of this will give me acceleration which I know is negative. So in 1 second this is the state. After 1 second till 2 seconds, many students commit a mistake of drawing the graph this way. This will be wrong because if I give this graph here, the slope will become positive. For me, the slope is yet negative from 1 second to 2 seconds also. So gradually the graph will come till here and the slope should continue to be negative. How justified are you? Have a look at this. At 2 seconds, I should get minus 9.8 meters per second of a velocity. At 2 seconds, undoubtedly the velocity will be the same as the velocity of projection. It comes back to the point of projection, but then here it will be minus 9.8 because it is in the downward direction. Rather, once the body reached the highest point and it took a turn, the velocity has become negative. That's why you are showing it in this particular quadrant. The velocity on the y-axis should become negative. The velocity on the y-axis should become negative. Is that making sense to all?
Yes, sir.
Now, one more very important point. If I consider the area of this to be S1 and area of this to be S2, till now we were using the word area under the curve and above the x-axis. Right? See a small catch in it. If I am adding up both the areas S1 plus S2, I will get the total area. If I am adding up both the areas S1 plus S2, I will get the total area. S1 plus S2, the total area here will give me the distance travelled. S1 minus S2, I will get the displacement. S1, this area minus this area, I will get the displacement. This area plus this area, I will get the total distance travelled. Is that clear?
Yes, sir.
Now, how do you draw for this problem displacement time graphs? When it comes to displacement time graph, watch out for this carefully. This is displacement and time. For the first half of the journey, for 1 second, this will be the state. Why will this be the state? Initially at time t equal to 0, the displacement is 0, you are starting off from the ground. In 1 second, you are reaching the point where the velocity should become 0. After 1 second, when you reach the highest point, what is happening to the velocity? It became 0. So the slope should be decreasing. In the first half of the journey, the body is going up. When the body is going up, the velocity is decreasing. Velocity is decreasing means slope should be decreasing. Now second half of the journey, in 2 seconds, you are supposed to reach from here till here. Why do you say that you should reach here? I should reach here simply because after 2 seconds displacement has become 0. Particle will come back to the point of projection. Now there are two ways in which, please concentrate. Now there are two ways of reaching this particular point. Either this or this. Both of them are parabolas. Now which of them will be preferred? For me, the second one will be preferred because if I opt for this dotted line, for me slope is decreasing. If it is coming this way at the lowermost point, there is a possibility slope becomes 0. And slope should not decrease for me when I am going from 1 to 2 seconds. From 1 to 2 seconds for me, the velocity is increasing. Maybe negative velocity it is okay, but when the body is coming down, the velocity is increasing. For me, if I opt this, the velocity will be decreasing. So I removed this option. For me, slope is increasing here. And the increasing slope, if you observe very carefully, the slope of this will be negative. If I ever draw a slope here, the theta value will be in the second quadrant. So the slope will be negative. Should you have the slope negative? Yes, I should have the slope negative because the displacement time graph slope will give me velocity. And velocity from 1 to 2 seconds is negative velocity. It is coming down, but at the same time the slope should be increasing. For me, this graph the slope is increasing. This graph the slope is not increasing. Is that clear? Yes or no? Now the same thing. If I would have asked for speed time graph, if this would have been speed time graph, now this is 1 second and 2 seconds. Undoubtedly this will come this way and this way. Speed time graph is okay. He is not speaking about displacement time. Speed time, this would be the graph. And if you ask me for the distance time graph, If this were distance and this were time, this is 2 seconds and 1 second. Till when? Remember, when the body is traveling in one single direction, distance and displacement is the same. Suppose I am traveling in this direction, distance and displacement will be the same. So the first half of the journey is the same. Parabola like this. Second half of the journey, as I am coming down, the displacement would be decreasing, but the distance would be increasing. You know the difference between the two? Yeah. The distance is increasing in the sense it will go this way. Why should it go this way? The slope also should be increasing. Why should the slope increase? That will give me the speed. As a result of it, that will be the distance time graph, and this will be the displacement time graph. Is the problem completely clear to all?
Yes, sir.
Write down a problem. A body is dropped from a height of 19.6 meters. It strikes the ground and rebounds to the same height. Draw the ST, VT, AT graphs, assuming the point of projection as the origin. That means you are dropping from here. Height of this is 19.6. One important catch in the problem is it strikes the ground and rises up, and it reaches the same point. That means if it is striking the ground with a velocity of u, it must rise up with the same velocity, only then it will reach the same point.
Yes, sir.
Now firstly, how much time does it take to come here? S is equal to half dt square. Half into 9.8 into t square. 2 into 19.6 by 9.8 is t square. T is equal to 2 seconds. It takes 2 seconds to reach here. Another 2 seconds to reach the highest point. Second, what is the velocity with which it strikes? V is equal to u plus gt. Final velocity is v equal to 0 plus 9.8 into 2. 19.6 meters per second. That means it is striking with 19.6. It will rise up with 19.6 to reach the highest point again. And for me, everything in the upward direction is positive. Everything in the downward direction is negative. Is the information clear? Will you attempt the ST, VT, AT graphs?
Yes, sir.
Quick. ST means non-distance time, displacement time. VT means velocity time. Have a look at this. Firstly, I'll draw the acceleration time graph. Whether the body is going down or going up, all throughout the acceleration is only in downward direction. Whether the body is going down or going up, acceleration is all throughout in the downward direction. For a total of 4 seconds, it takes 2 seconds to come down and 2 seconds to go up. For a total of 2 and 4 seconds, the acceleration will be minus 9.8 meter per second square. Fair enough. Now look at the velocity time graph. As it is going down, the velocity is increasing. As it is going down, the velocity is increasing. And you said everything in the downward direction is negative.
Yes, sir. Yes, sir.
So whole of the first half of the journey should be negative.
Yes, sir.
Whole of the first half of the journey till 2 seconds should be negative. And it should acquire a velocity of first to 2 seconds. Velocity must be negative. It is in the downward direction. But yet velocity should be a straight line because the slope of this is constant, that is acceleration. And is the slope positive or negative? Slope is negative because acceleration is negative. First 2 seconds, this is the graph, and what is the velocity it acquires? It is minus 19.6 meters per second.
Yes, sir.
Now just after colliding with the ground, the velocity is right now in the upward direction. Just after colliding with the ground, the velocity is in upward direction. Once the velocity has become upwards, remember, once the velocity has become upwards, it becomes positive. And it's stuck with 19.6, it is rising up with 19.6 means this will be 19.6. So the moment it collides, it becomes plus 19.6.
Yes, sir.
And from there it becomes 0 again when it reaches the highest point. So when it is going up, velocity is positive, so it will be in this quadrant. But at the same time, remember, though the velocity is positive, acceleration should be negative. So the slope should again be negative. And at 4 seconds the velocity should become 0 when it reaches the highest point. See the graph very carefully and you will be drawing the speed time graph. Speed time graph for 2 seconds and 4 seconds. First do it, then we will go to displacement time graph. The velocity speed time graph will be, the first part will be like this. No, speed will not have a direction, it's increasing. This should be the speed in the first half because speed will not be taking positive or negative. So the first half of the journey the speed is increasing. The second half of the journey the speed is decreasing. And the slope of speed will not give you acceleration. Remember, slope of velocity time graph will give you the acceleration, but slope of speed will not give you the acceleration. Don't tell me the slope of this will give you the acceleration. Your slope will be positive. The magnitude of acceleration can be got. Right? Now come to displacement time graph. The displacement time graph here for 2 seconds or 4 seconds. The displacement time graph for 2 seconds or 4 seconds. Watch out for this. I am starting from here and after 2 seconds I have a total displacement of 19.6. Negative or positive? Negative. After 2 seconds it has travelled a total displacement of minus 19.6 because everything in the downward direction is taken to be negative. So 100% I will have to come to minus 19.6 meters after 2 seconds. Now I will have to come in the form of a parabola. The path I will have to follow to come from here till here will be parabola. There are 2 ways I can draw it. One will be this and one will be this. Now this will be decreasing slope, this will be increasing slope. Maybe negative, but it is increasing slope. Now when the particle is coming down, is the velocity increasing or decreasing? So velocity should be increasing, implies the slope should be increasing. For this the slope is increasing, while for this the slope is decreasing. You can see that the lowermost point slope becomes 0 for this. So remove this option out of the question. Now come to the second. From 2 seconds the displacement after 4 seconds should become 0. After 4 seconds the particle comes back to the point of projection. If the particle comes back to the point of projection, it should be reaching this particular point. Displacement will be 0. Right? Displacement will be 0. It should be reaching this. Either it should be coming in this way or it should be coming in this way. If it comes in this way, for this the slope is increasing. If the slope is increasing, for me velocity will be increasing. That doesn't happen. Velocity is decreasing. So remove this. Second option. How reasonable are you in keeping both the displacements only on this quadrant? That means you are telling me all throughout the displacement is negative? Yes. It is going down. It was negative. After collision, even when it was coming up, it didn't cross the origin. It was below the origin. So at any particular point I want the displacement from the origin I should be going down. At any particular point I want the displacement from the origin I should be going down. Right? From the origin if it is going down, as a result of which displacement all throughout is negative. If the displacement all throughout is negative, it will be in this particular quadrant. Is the logic clear to all?
Yes, sir.
By the way, how do you define average velocity? Average velocity will be total displacement by total time.
Yes, sir.
Total displacement by total time. Average velocity. Page number 75. On that page, I think from the 6th question onwards. Exactly. Lift the book slightly above. Slightly above. Take it above. Vertically above. From the 6th question, whole of that page. How many questions you have on that page? Till 13th question. And the next page. Turn the next page. Right. 14, 15, 16, 7, 16th question. Up to the 16th question here. 6th question to 16th question. Right. On that page, that was page number 75. Am I right? Page number 75. 6th question to 16th question. 6th question.